Good morning, students. So myself, JNTUK from EC Department, Chevrolet Engineering College. Today, we are going to discuss about the inverse Fourier transformation examples. Inverse Fourier transformation examples. In the last class, also, we discussed some examples on inverse Fourier transformation. That is, find the inverse Fourier transformation of x of omega by using the partial fraction expansion method, and by using the convolution property, and by using the formula. Okay. Now, another example, find the Fourier transformation of the function. Find the Fourier transformation of the function x of t minus t naught. According to the shifting property, the exponential is multiplied with the t naught. But given here the x of t minus t naught as e power minus t minus t naught and the mu of t minus t naught. How to find out the Fourier transformation? So Fourier transformation formula is the Fourier transformation of x of t is equal to x of omega. Then the Fourier transformation of x of t minus t naught, according to the property, the x of omega is multiplied with the e power minus j omega into t naught here. That is a time shift property. So the Fourier transformation of e power minus t mu of t is a 1 by 1 plus j omega. Okay, according to the time shift property, the x of t minus t naught, because it is a t naught samples is shifted, its Fourier transformation is, since x of t, you'll get the x of omega in frequency, and the t naught is samples is shifted, e power minus j omega into t naught. Okay, the given function is x of t minus t naught, and we know the Fourier transformation of e power minus t mu of t. The Fourier transformation of e power minus t mu of t is 1 by, actually it is a is there, e power minus a t mu of t, a plus j omega. So now it is in the e power minus t mu of t, its Fourier transformation. So a is a 1. A is 1, so the 1 by 1 plus j omega. 1 by 1 plus j omega. Got it? 1 by 1 plus j omega. So we need that is x of t minus t naught. X of t minus t naught. Got it? So by using this property and by using the e power minus t mu of t, the Fourier transformation means x of omega is there. So the x of t minus t naught, its a Fourier transformation is e power minus j omega into t naught, shifted value, and in the denominator is a 1 plus j omega, that is x of omega is equal to x of omega. Okay, so substitute this x of omega as 1 by 1 plus j omega, and it is shifted with the t naught samples is multiplied with the negative exponential with that t naught sample. So the Fourier transformation of e power minus of t minus t naught into mu of t minus t naught is e power minus j omega t naught by 1 plus j omega. It is a Fourier transformation. And another Fourier transformation also there. You have to find out the given function here. X of t is equal to mu of t plus 1 minus mu of t minus 1. Mu of t plus 1 minus mu of t minus 1, and the cos function is multiplied here. Cos 2 pi into t. Cos 2 pi into t. So cos 2 pi into t in exponential value is e power j 2 pi into t plus e power minus j 2 pi into t by 2. Okay. So its Fourier transformation is 1 by 2 into e power minus j 2 pi into t. So Fourier transformation of 1 is, we know, the 2 pi delta omega, and Fourier transformation of e power j omega naught into t is 2 pi into delta omega minus omega naught. So then finally the Fourier transformation of 2 pi into t is pi into delta, because already the 2 is gone, pi into delta, and here the omega minus, instead of omega naught is a 2 pi is there, so omega minus 2 pi, and this is omega only, my students, omega minus 2 pi and omega plus 2 pi is only the Fourier transformation of cos 2 pi into t. But what about the Fourier transformation of the multiplication factor mu of t plus 1 minus mu of t minus 1? Okay, for this, you have to find out, first of all, the equation here, the mu of t is in the exponential, mu of t plus 1 minus mu of t minus 1. We know the mu of t graphical representation is like this. Mu of t is 1, its magnitude from 0 to infinite, as a t is a variable. Mu of t plus 1, mu of t plus 1 means it's advanced function, so it is shifted towards the left side as a one sample. Its magnitude is also 1. Then after, mu of t minus 1, mu of t minus 1, mu of t is from 0 to infinite, the value is 1, and mu of t plus 1 is from minus 1 to the infinite, the value is 1, because advanced function shifted towards the left side. Now it is a delayed function shifted towards the right side. So it starts from the 1, its magnitude is also 1. And I need that it is a mu of t plus 1 minus mu of t minus 1. Subtract the two functions here, subtracting the two functions. From minus 1 to 0 and 0 to 1, the value is a 0 here. The value is a 0. The total is a 0. So mu of t plus 1 minus this function is 1 minus 0 is a 1 only. 1 minus 0 is a 1. So from minus 1 to 0 to 1, okay, the magnitude is a 1. And what about the from 1 to infinite? Here also the 1 is there. From 1 to infinite, the 1 minus 1 is a 0. So the function is a mu of t plus 1 minus mu of t minus 1. Only the magnitude is 1 from minus 1 to 1 only. And the remaining is a 0. So value is totally 0, and here also the total is 0. You can call it as a rectangle function. So the Fourier transformation of this function is, what is the Fourier transformation formula? The x of omega is equal to integral minus infinite to infinite x of t e power minus j omega t dt. Okay, what is x of t here? The value is from minus 1 to 1 is a 1 only. So the integration becomes minus 1 to 1. The x of t, the value is 1. 1 to 1. The value is 1 into e power minus j omega t dt. E power minus j omega t dt. Got it, my students? And what it is the Fourier transformation is e power minus j omega t whole divided by, with respect to, we are applying the time. So minus j omega is a coefficient, and 1 and minus 1. Upper limit is 1 and the lower limit is a minus 1. So now I am substituting the upper limit as a t value is a 1. T value is a 1. It becomes of minus j omega minus e power minus already there. Now you can substitute as a t as minus 1. it becomes of plus j omega by, already there is a minus j omega is there. So it is a Fourier transformation. Here the minus 1 by j omega e power minus j omega minus e power plus j omega is e power plus j omega. And that is equal to, take this minus as a term and subtract, change the sign here. It becomes of e power j omega. Negative sign is becomes a positive, and here the minus e power minus j omega whole divided by 2j I'm taking here and multiplying with 2. Already the omega is there, you can write this as omega. So what is this function? E power jx minus e power minus jx by 2j is a sine function. So 2 by omega into sine omega. You see here the 2 sine omega by omega is a Fourier transformation of only this function. And what is the Fourier transformation of this function? Is pi into delta of omega minus 2 pi plus pi into delta omega plus 2 pi. Got it, my students? We got the two functions as consider this as a y1 of omega, y1 of omega, the x1 of omega here. See, by using the multiplication property, the time is protected. These two are the time protected. What is the frequency? Frequency can apply the convolution 1 by 2 pi into x1 of omega convolution with the y1 of omega. Got it, my students? So x1, they consider this x1 of omega is a 2 pi to x1 of omega is x1 of tau here as of the frequency 2 pi into tau by the tau, and the y value is considered as wherever that is a y1 of y of omega is there, omega minus tau is a tau, okay, omega minus 2 pi, omega minus 2 pi, wherever the omega is there, you can substitute that omega minus 1 and omega minus 1, that plus 2 pi is already there. Okay, my dear friends. So from this function, I am writing here that we got the two values. One is 2 sine omega by omega, and another one is pi delta omega minus 2 pi plus pi delta omega plus 2 pi. So according to the convolution of x of omega with the convolution of y of omega, consider this as y of omega and consider this as x of omega. So what is the formula for this one? Minus infinite to infinite, the convolution of the two functions. X of tau, y of t minus tau, theta. X of tau, y of t minus tau, theta. Okay, you see here, x of tau, y of omega minus tau theta, because here the function is of omega. Whenever it is the t is there, let it be without confusion, x of t, y of t. Then only this is the equation. Now, instead of t, there is a x of omega with the convolution of y of omega. Now it becomes of integral minus infinite to infinite, x of tau, y of the t is now the omega is there, omega minus tau theta. Okay, this is the second function. Then that is equal to integral minus infinite to infinite. What is the x of omega? We considered 2 sine omega by omega. What is instead of omega here, it is a tau is there. So 2 sine the tau by the tau. 2 sine tau by tau. And what is the y of omega here? Pi delta omega minus 2 pi. It is omega 1, right? Omega minus 2 pi plus pi delta omega plus 2 pi. So what is the instead of omega here? Omega minus tau. Replace the omega as omega minus tau. So it becomes of pi into delta of omega as omega minus tau minus 2 pi whole multiply here plus pi into delta omega minus tau plus 2 pi. Okay. Whole multiply and the d tau. Now we substituted the x of omega, y of omega in the convolution equation. In the convolution equation and split the two parts as an integral here. As an integral. Integral minus infinite to infinite 2 sine tau by tau 2 sine tau by tau into pi delta function is there. What is the delta? Delta omega minus 2 pi minus tau into d tau. This is the first function. And here in this formula, there is a 1 by 2 pi into the convolution is there. So here there is a convolution is there, 1 by 2 pi into that convolution. So for every term, there is a 1 by 2 pi is a multiplication factor, 1 by 2 pi. So here also 1 by 2 pi is there for the first function. For the second function also 1 by 2 pi. The integral minus infinite to infinite is the same 2 sine 2 pi, 2 sine pi tau by tau is multiplied with a pi into delta of omega plus 2 pi minus tau. Omega plus 2 pi minus tau into d tau. So in this, the 2 pi is here, the 2 and pi is get cancelled, 2 pi and the 2 and pi is get cancelled. Okay. Now, the integral minus infinite to infinite, sine tau by tau delta omega minus 2 pi minus tau d tau. And another function is sine tau by tau, the delta of omega plus 2 pi minus tau d tau. Okay, my dear students. So I'm rewriting this function as integral minus infinite to infinite sine tau by tau and delta of omega minus 2 pi minus tau d tau plus integral minus infinite to infinite sine tau by tau delta of omega minus omega plus 2 pi minus tau d tau. Okay, my dear students. So in this function, you have to use this formula is there here. Integral minus infinite to infinite x of t delta of t minus t naught. Delta t minus t naught. Okay. Means that is whenever any integral with respect to the multiplying of delta function, the same signal will get x of t naught. If it is a x of t delta of t means x of t only. X of t delta of t minus t naught or k is there x of k. Whatever the sample is shifted in the delta function, at that sample only will get the x of t.